Okay, I am going to go over 1 through 5 in this video of your math review sheet for the week. And again, remember, whatever number 1 is, number 11 is going to be the same problem on the back. Same with number 2. Number 2 is going to be just like number 12 and so forth. So once you get the front completed, you should be able to get the back. If you're having any trouble, always refer back to the front and the problems that we went over together. So let's look at number 1. And anytime that I'm doing this, if you need to pause the video, go ahead and pause it while you're doing your work along with me. It's very important that you do show your work. If I have something down, then you need to have something down as well. I'm not going to go through all the answers. I'm kind of going to guide you and lead you in the right way. Some of these you should be very familiar with at this point. But I will cover 1 through 5 right now. Again, show your work. If you need to, do it on another piece of paper. You don't have to try to cram everything into the little box that they give you here. So let's look at number 1. Number 1 says, list all of the factor pairs for 23. Then label it prime or composite. Okay, so first let's talk about factor pairs. Factor pairs are simply two numbers we multiply together to get a number. Okay, let me turn this page. Now, let's talk real quick about prime and composite. So, a prime number only has two factors, 1 and the number itself, meaning I can only multiply 1 and the number to get that number. For example, 5. The only way I can get 5 is to multiply 5 times 1. That'll give me 5. There's nothing else that I can multiply together that's going to give me that's going to give me 5. So 5 is a prime number because it only has two factors, meaning 1, 2. Okay? Two factors. Same thing with number 7. So 7, I can multiply 7 times 1. That gives me 7. But that's it. I can't multiply any two numbers together besides of 7 and 1 that will give me the answer of 7. So again, it only has two factors, 7 and 1. So a prime number is a number that only has two factors. Okay? Now composite has more than two factors, meaning I can multiply more than two numbers together to get that number. So for example, the number 10. Okay, if I wanted to find my factors of 10, I always know that I can start with 10 times 1 equals 10. Okay? Then I ask myself, is there something I can multiply? I like to try to go in order. So if I use 1 already, I'll go to 2. So is there something I can multiply by 2 to get me 10? And I can multiply 5 times 2. That gives me 10. Okay, I know there's nothing, I can't multiply anything by 3. I can't multiply anything by 4. And then I've already used 5 here. So the number 10 has 1, 2, 3, 4. 4 factors. So that makes it composite. Okay? Let's do one more. Let's do the number 12. Okay? I know I can multiply 12 times 1 to give me 12. I know I can multiply 6 times 2. That'll give me 12. I also know that I can multiply 4 times 3 together, and that will get me 12. Okay, so 12 has a total of 1, 2, 3, 4, 5. It has 6 factors. Okay, so a prime number has only 2 factors. A composite number has more than 2 factors. So in your problem that you have to figure out for number 1, you have to list the factor pairs of the number 23. So the number 23. List the factor pairs, the numbers you can multiply together to get that number. If you're having trouble with your facts, use a matrix. Use a multiplication chart. There's one in your planner, or you may have one in your folder as well. Okay? Let's look at the next problem. The next problem should look really familiar to you because we just finished this unit a couple weeks ago. You're simplifying 6 plus 4 times 3. Okay? Let's take a look at that. So again, going back, we remember from using our strategies on solving order of operations. We know we do parentheses first, then we do exponents, then we do multiplication or division. That's what the M or D stand for, and whichever comes first going left to right. So if multiplication comes first, we do that first. If there would be division first, we would do division first. And then we have addition and or subtraction. So again, we flip-flop the two based on what comes first going left to right. So in this problem, we have an addition 6 plus 4 times 3. So based on our order of operations, okay, multiplication comes first. So we'll start off by doing that. Okay, you should 4 times 3. That will give you the 4 times 3, that answer. And then make sure, once you get whatever answer that is, I'm not going to do it for you, you bring down the problem plus 6. And then that would be your last step. Okay? That's number 2. Let's look at number 3 now. 3 is a word problem. It says Sarah scored 2,153 points in a video game. That was 1,526 points more than Grace on the same game. How many points did Grace score? So again, Sarah scored 2,153 points in a video game, and that number was 1,526 points more than Grace on the same game. How many points did Grace score? So in this problem, I know that Sarah scored 2,153, and that was 1,526 points more than Grace. Okay? So you have to determine what operation would I use here. Okay? She scored 2,153 points, and that was 1,526 points more than Grace. So this is going to be a subtraction problem. Okay? Make sure when you're subtracting, make sure, like for the first part of the subtraction problem, you cannot subtract 6 from 3. Okay? Because 3 is smaller than 6. So you're going to have to borrow. So don't forget to do that as you're working through this problem. You're going to have to do that in a couple different places. Okay? Make sure with your word problem, make sure you have a label. If you do not have a label, your answer will be wrong. Okay? Let's look at number 4. Number 4, again, should look very familiar because this is what we're actually working on now in math class. You have 988 divided by 7. 988 divided by 7. Okay? So again, we're going to set it up using the partial quotient method. I know that you have learned both at this point, but this is the one you're probably the most familiar with. This is the one we've been working on the longest. So I will get you started with this, and then you will finish the problem. Okay? So once I set my problem up, you need to set it up as well. I ask myself, can 7 go into 9? Okay? And I know 7 can go into 9. And I know 7 can go into 9 one time. So over here, I'm going to write my factors. So I know 7 times 1 equals 7. And I'm going to use my powers of 10 now. 7 times 10 equals 70. 7 times 100 equals 700. Now I know I'm trying to get into 988. 700 is pretty close. So I'm going to go ahead and pull out 100 groups of 7. And that will give me 700. Then I subtract. 8 minus 0 is 8. 8 minus 0 is 8. 9 minus 7 is 2. Okay? Now at this point, I start the whole process over again. Except this time, instead of using 988, I'm using 288. So I ask myself, can 7 go into 2? It cannot. 2 is smaller. So I ask myself, can 7 go into 28? I know that 7 can go into 28. And I know it can go in 4 times. So up here, I'll start to write my factors again. 7 times 4 is 28. And I am going to stop here with this problem. You need to go ahead and finish this problem out by continuing with the powers of 10 with where I started 7 times 4 equals 28. Okay? Again, at this point, this method should be very familiar to you. So go ahead and finish working this problem out. Remember, at the end, you should add up this column and then any remainder that you have left. Okay? And the last problem I'm going to go over is number 5. Okay? Number 5 says, write the following fractions in order from least to greatest. From least to greatest. And you have 1/3, 1/8, 1/12, and 1/2. So we're putting them in order from smallest to biggest. Okay? What I have already done ahead of time is I drew a picture. Okay? And I try to make each picture, each rectangle the exact same size, if you notice. And the only thing that changes is the number of parts that I have. Okay? So this one over here has 3 total parts. This one here has 8 total parts. This one here has 12 total parts. And this one here has 2 total parts. Okay? So they said 1/3, so I'll just color in 1/3. And they said 1/8. So again, 1/8, and then 1/12, and then 1/2. Okay? So once you have this visually, it's easy to see which is the smallest, and then go from there. So in my picture, I mean, I'm not exact because I just kind of did it freehand, but if I look closely, 1/12 is actually the smallest. It's smaller than 1/8. So I know 1/12 would be my smallest fraction. Okay? My next smallest would be 1/8. Okay? And then you can finish off the other 2 fractions by just visually looking at them. Okay? So this was number 1 through 5. Again, make sure you have all your work shown for these problems. Again, it's going to be a lot easier if you can do it on a separate sheet of paper and you can staple it. If you don't have enough room, instead of trying to cram everything into those boxes and making silly mistakes just based on trying to cram everything in. But bring it in, we'll check it, and again, refer to the problems on the back, 11 through 15, because they're going to be the same exact type of problems that we had here. Okay?